Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss the concept regarding hydraulic gradient line and total energy line. So this concept is required actually when you do some kind of analysis, fluid flow analysis. This concept is required in that condition. So let's discuss about this HGL and TEL. Basically, HGL equal to, we can define this. This is the sum of pressure head. This is the sum of pressure head, and this is the sum of, you can say, datum head. So HGL is nothing but it is the sum of pressure head and datum head. Now, why this HGL and TEL is required? I already told you that this is required when there is a analysis need to be done on the pipe flow. And similarly, this is TEL. We can define. Total energy line can be defined. This is pressure head plus kinetic head plus datum head. All this sum is equal to total energy line, and this pressure head and datum head is equal to hydraulic gradient line. So before going to the explanation part, let me tell you what is this pressure head. So pressure head is equal to the intensity of pressure with respect to the specific weight. Okay, specific weight is nothing but we can write rho g, or sometimes it is to written like P1 by small w. Okay, and this is datum head is nothing but Z, the height of the fluid flow from a datum line or from a reference line. Similarly, here also we can write same thing. This will be like P1 by rho g, and this is kinetic head is nothing but this is related to kinetic energy. So half mv square, or you can write v1 square by 2g, and plus this is datum head. As I told you, datum head is nothing but the height of the fluid from a reference line, that is Z. So let's define this concept, how it can identify or how we can understood this concept. So let's consider a pipe flow. Let's consider a pipe through which the fluid is flowing. Okay, and while the liquid is flow or the fluid is flowing through this pipe, we have a velocity and we have a pressure of this point at the inlet condition. And similarly, when the fluid is fluid flows through the pipe and is coming out from this outlet part, we will also have a velocity value and also have a pressure value. But this pressure value may not same as the initial. So there will be a pressure drop will be there while the fluid is flowing through the pipe. So let's see how this pressure drop will be there and how this velocity will be, whether the velocity will remain same or different. Let's discuss about this. So when the fluid is flowing, suppose, okay, throughout this pipe surface, it is flowing like this, and inside the pipe also will have a pressure at the fluid, the liquid, in this liquid also have a pressure. Now, to identify the pressure at this point, to identify the pressure of the fluid at this point, let's insert a tube. Let's insert a glass tube inside this pipe. Okay, and so when you insert this tube inside the pipe where this fluid is flowing, so you can see there is a rise in liquid in the tube. So this rise of liquid, okay, this rise of liquid is called actually the pressure head. Okay, it's called actually the pressure head. Pressure head is nothing. Why it is pressure head? Now, due to the pressure, there is a rise in water level from this pipe to this tube. So how much how much rise in liquid in this tube with respect to the intensity of pressure. That's why, okay, let me draw a center line. This is the suppose center line of the pipe. So datum line, this datum head, okay, that can be considered by considering this is the datum line or reference line, or else what we'll do, we'll take another one line which is called a datum line, and by referring this line we can identify what is the datum head. So how to refer this line? That means we let consider this is the reference line is there. This is called, sometimes it used to call, like some books it is it is given datum line, or some book it will be given like a reference line. So both are same. By taking this reference of this line, so what is the head or what is the height of this fluid flow at the inlet of the pipe? So this is nothing but Z, or we can get Z1 here. So up to this level, this is the Z1. Now, though you want to measure the pressure or head at this inlet of this pipe or this section pipe, so from here to here, from the center line of this fluid, okay, to at what level the liquid was raised in the tube. So this is nothing but the pressure head. So this is P by rho g. So this is to happen because of the pressure difference of between this fluid which is flowing in the pipe and the tube inside that one. So that is called pressure head. So as per the definition of HGL, what it defines? Now it is the sum of pressure head and datum head. So datum head is what? Datum head is the distance from the reference line to the center line of the fluid at inlet condition. This is Z1. Similarly, this is pressure head P1 by rho g. So this one we can write Z1 plus P1 by rho g. This is about the what? HGL at the inlet condition. Now same thing, let's consider another one tube at the outlet, near to the outlet of the pipe, or else with some distance from the inlet conditions or from the starting conditions, we can say. So here also we can able to identify like some there is a rise in water, or there is a rise in liquid level at the second condition. So here also we can see the rise in liquid or rise in the water level in this point will be slightly lower than the at the initial conditions. Okay, so this is also due to the difference of pressure in this liquid, in this tube and the pipe. But what is the difference? Pressure means what? Now here at this level we have different pressure value will be there, and here we may have different pressure value will be there. Okay, so at this point, what is the pressure value is there? Based on that, how much liquid was raised in this tube. So that we need to identify. So similarly, here also we can define this is the height. This is the height of second section. So if you consider this is section 1, this one, and this one you can consider section 2. So at this point, what is the head is there? What is the datum head with compared to the datum line? So this one we can give Z2. Similarly, from this reference line at this tube, what is the rise in liquid? And that is called the pressure head at the second condition. So this one also can be mentioned P2 by rho g. Now here the pipe is horizontal condition, so we can get Z1 equal to here Z1 equal to Z2. But when the pipe will be inclined condition will be there. When the pipe is in inclined condition, at that time our Z1 and Z2 both will be not same, both will be different. Suppose here if you consider this is datum line or reference line is there, as I told you. So based on this reference line, let's find out what is the height of this liquid. Okay, what is the height of this liquid, or what is the head of this liquid from the datum line? So this is Z1 at this point, inlet point. But when the fluid is flowing through this pipe and it is leaving this outlet condition, so at this condition, what is the height is there, or what is the head of this liquid is there? So that is Z2. This is for the inclined condition. Okay, now for this is inclined, this is horizontal. So similarly in the horizontal condition also we need to identify the datum head at inlet and outlet condition, and we can here we can see though it is horizontal, we can consider Z1 equal to Z2. Okay, this is about the datum head. Now, at this point, if you see, these pressure labels are different at first section and second section. This also is to one of the reason for the losses, or we can say that due to the losses in this pipe, losses in the pipe maybe happened a major loss and minor loss. Already we have discussed previously. So major loss used to happen due to the friction factor in the pipe. That means when the fluid is flowing and surface of this pipe, between this there is a friction will be there. So based on the surface roughness, your friction factor depends. So due to the friction factor also, there will be a pressure difference will be there at this zone and this zone, and because velocity also will be varies by that. Okay, so here if you consider your pressure P1 value, that pressure intensity of pressure at this point, okay, will be more than the pressure intensity of at the second point. Okay, due to this there is a difference in head also. So due to this head difference means what? At this point, what is the H will be there? This H. Okay, this H how much will be there? Now we know that formula P equal to rho G H. Okay, P equal to rho G H. Now this one we have already discussed in the hydrostatic law. There we got this formula P equal to rho G H. Now at this point, what is the height is there? How much height in reg in this? By that we can calculate the pressure intensity. So the pressure intensity here will get more than this one. So here we can say due to this height, that means H1 also will be more than H2. Okay. Now these things don't let right outside here. Now this distance or this incline line is nothing but it is called as HGL. This is called as HGL, hydraulic gradient line. Now if you see, this is the first position. Now if I take the second one position here and I'll put some tube here, and I can find out that the level of this water is came a little bit down here. Again, if I take I'll insert a tube here, again I can see the water level rises in the tube up to this much distance. So up to next level we can get here. So by like this experiment, we can join all these points and we can find out this is the HGL, hydraulic gradient line. Okay, now let's come to the TEL. TEL in the sense total energy line. So in this total energy line, we need to consider the velocity head. So the velocity head, when we can consider, now when there will be a fluid flow will be there, and the fluid is flowing with some velocity. Okay, now so when velocity of fluid will be like when the fluid is flowing in that, so there we can see along with this this is datum head, again here pressure head is there, and due to this velocity of this fluid, there will be a rise in height in this. There's a rise of liquid here, we can rise here. So this rise of height, okay, due to this fluid flow or due to the fluid velocity, that will be give you a value here. Okay, so this is nothing but V1 square by 2g. So this is velocity head. So what is the velocity at this point? The V1 and the intensity of pressure P1. So this velocity head V1 square by 2g. Similarly, at the second tube also, when there is a fluid flow is there and we are considering the velocity at this point, due to the velocity at this point, again slightly increment will be there in this liquid level at the second zone. So this is this line. If I join this one, this inclined line, this is called total energy line. This is called total energy line, and this height is nothing but our V square by 2g. This is your kinetic head. This is your kinetic head. Now, datum head, pressure head, and kinetic head. Similarly, datum head, kinetic pressure head, and kinetic head. So this is about the total energy line. So because these things already we have discussed regarding our Bernoulli's equation, all these things. Okay. So Bernoulli's equation, what used to say? Now P1 by rho g plus V1 square by 2g plus Z equal to, here Z1 also you can keep, equal to P2 by rho g and plus V2 square by 2g plus Z2 and some losses is there. some losses is there. As I told you that when there is a flow, liquid flow is there in the pipe, some losses will be there. That losses is nothing but HF. So this is the Bernoulli's equation. Okay. Now this is about the hydraulic gradient line and total energy line. Now the thing is, when there is a fluid flow is there, then we can say this one. Now if you want to, this is total energy line. Now if I draw the total energy line like this, okay, if I draw the total energy line like this is to happen because of the losses. Because of the losses in the fluid flow, energy losses in the fluid flow. That's why the velocity gradient also decrease, and the pressure gradient also there is a pressure difference in pressure value and difference in velocity value. That's why this differences came. If suppose there is no loss of energy during the fluid flow, when there is a fluid flow is there, there is no loss of energy in that fluid, in that pipe, then at that condition our TEL will be, total energy line will be there. At starting point, what position is there? At this next point also, next position also, we have the same position will be identified at this top, at this position. That means there is no loss was considered, or no loss happened during the fluid flow in the pipe. Okay, so this is all about the details in the HGL and TEL. Now the question is, the point is, why it is most important. As I told you, this is required for the pipe flow analysis. This is required for the pipe flow analysis. Now apart from that, what are the other things we can identify from here? As I told you, you can see, yeah, I'll tell you. First point, yeah, let me write here. First point, I can say that when there is a fluid flow is there, and what are the flow activities happening here, we can easily identify by the energy losses. Okay, if you see the visualization, by visualization, we can identify what is the losses of energy is there during this fluid flow. And next, what I can say, there is a yeah, the next is pressure. What about the, as I told you, this here P1 and P2 energy losses, visualization of energy losses you can write for. And what about the pressure difference? What about the pressure difference in the pipe? So that also can be identified. Now if you can able to identify the energy loss and the pressure loss, immediately we can take the preventing we can take the prevention for this. So to avoid this one, to avoid these losses, like, you know, there is some pressure drop will be there, okay, or there is some you can say some maybe cavitation may be formed due to that pressure losses are happening. So that thing can be taken as a preventive. So along with that also, I can say that, you know, you can optimize that, the engineer can optimize that, whether any other things can be taken, other things in the sense, suppose any kind of pump is there, so pump placement is perfect or not, or whether a pump placement need to be changed, okay, and also, you know, some kind of valves will be there. So that means we need to optimize the things. So optimization can be done in case of these things, whether the pump placement is correct, or pump replacement is required, or whether cavitation formation happen in the pipe, and whether valves are properly you know, placed. So all the things need to be can be identified by this concept. So I hope you understand this theory, HGL and TEL. If you are having still doubt regarding this, you can give a comment on that. Thank you all.